All right, in this section we are talking about solving equations that have radicals in them. And our general rule of thumb is to get the radical isolated. That means all by itself, okay? And then after you get it isolated, you're going to square or do whatever you need to do. In this case, on number 9, we're going to cube both sides, but I'll just put cube or square both sides, whatever you're supposed to do. Now, this one's going to be an easier one. 1 through 9, they were pretty easier. The ones after that are not as quite so easy, so I'm going to just do one of these and spend more time on video on the harder ones, because sometimes you have two radicals in an equation. So we'll look at that here in a minute. Okay, so if I want to get the radical by itself, here it is. And so to get it by itself, I could move the 5 away from it. It's added on. I could say the opposite is subtracting it. That would make it add up to 0 and disappear on this side. And over here it would be negative 2. So I've got the cube root of 2d is equal to negative 2. Now, how do I get rid of a cube root? I cube. The opposite of cube rooting is cubing. So what I'm going to do is I'm going to take each side and I'm going to cube it. Okay? Now the cube root of something cubed is just whatever was underneath that radical to begin with. It's a 2d in this case. And here negative 2 cubed would be negative 2 times negative 2 times negative 2. It would be a negative 8. Okay? And if I want to get d by itself now, all I got to do is divide both sides by 2. And then those will cancel out, and I'll get d equal negative 4. So my answer is negative 4 there. And just checking to make sure I didn't mess anything up here. Yeah, that's what the book has also. And again, they're going to write it in set notation. On 15, we still have one radical, but there's going to be a little glitch in this one too. We only want to get, just like the last one, we want to get the radical by itself. And there's only one radical, and we're always happy of that. Here it is. So to get it by itself, I can subtract t from both sides. Okay? What I would have after that is the square root of t minus 2 is equal to, I could write negative t plus 4. I'm going to write 4 minus t here, because if you think about it, what am I going to do next? I'm going to square both sides. So I'm going to think the whole thing, 4 minus t, I'm going to put it in parentheses, I'm going to square both sides. And it'll just be easier to multiply out if I don't have a negative t sticking out at the front. So that's why I chose to do it that way. All right, the square root of something squared is just what's under the radical there, the t minus 2. And on this side, I have to think, well, that is 4 minus t times 4 minus t. So that's going to be t minus 2 is equal to 16. Minus 14 minus another 4t is minus 8t. And then minus t times minus t is plus t squared. Oh, I got a square. Anytime I get a square on a variable, I know that I got to either do factoring or the quadratic formula, something like that. So I know here that's probably what's going to happen. So I know when I have to do that in either of those cases, I'm going to move all the terms to one side so I can have 0 on one side and all the terms on the other, and that way I can factor it and solve it. So let me move the minus t over here. I'll line it up here. And to move the minus 2 over, opposite of minus 2 is plus 2. Those things add up to 0, don't they? But just got to make sure I do it to both sides. So I'll come back up here to the top. Here's what I have now. I have t squared. I'm going to put the square term first. A minus 8t and a minus 1t would be a minus 9t. And then I've got 16 plus 2, which is positive 18. And that's equal to 0. 0 is, don't have much room for it. So what I got to do now to solve is think, okay, what two numbers multiply to give me 18 and add to give me negative 9? Well, 6 times 3 is 18, and 6 plus 3 is 9. If I want to get a negative 9, I could say negative 6 times negative 3 is positive 18, and then if you add them, you get the negative 9. So this up here factors into t minus 6, t minus 3, equals 0. And then if I solve it, all I got to do is take each one of those and set it equal to 0. And then if I add 6 to both sides on this first one, that would give me t equals 6 as one solution. And if I add 3 to both sides over here, that's going to give t equal 3 over here. Again, I'm adding 3. It may look like a subtraction sign. It's just because I'm trying to write with a big old fat stylus tip, and that's the best I can do. So our answers are T and 3. Now, our answers are we got 6 and 3. But now sometimes we plug stuff in and it doesn't work. And when we plug stuff in and it doesn't work, that's called an extraneous solution. And in this case, one of these is not going to work. So let's go plug in 3 and 6 into this original equation. T minus 2 plus T is equal to 4. And we want to plug in, we've got 2 answers and we should check them. And in class, we'll talk about maybe how we could check them on the calculator. But we're going to do it algebraically right now because you really need to know how to do that. It's just kind of annoying to have to do this after you spent so much time on a problem. Let's try 3 first. Okay, if I plug in T is 3. 3 minus 2 plus 3 is equal to 4. Okay, well, 3 minus 2 is 1. The square root of 1 is 1. Okay, 1 plus 3 is 4. Yeah, that one worked out. That one's okay. So 3 is a keeper. It's a good answer. So let me write my answers up here. Let's see if 6 is a keeper. I'll do it in a different color. So if I plug in T is 6, 6 minus 2 plus, and then T is 6 is equal to 4. Well, what's under 6 minus 2 is 4. Okay? Square root of 4 is 2. Is 2 plus 6 equal to 4? No, it's not, is it? So 6 didn't work. So we're going to cross out 6. It didn't work. When we have radicals, this sometimes happens. Sometimes we get an extra solution that didn't work. That's called an extraneous, and you can see the word extra in it, solution. So if you give me 2 solutions, that's not quite right because you didn't check it to see if it worked. And you can check them by plugging them in and just seeing if they make the equation true. The reason this happens is we went in and when we started off with this equation, did it have any squares in it? No, it didn't. It had a square root and it had a t to the first power. If I'd had an exponent of 2, that means that I could have 2 solutions, but I don't have an exponent of 2 up there in that original equation, do I? So it's very possible that I'm not going to have 2 solutions. I probably am not going to have 2 solutions. And that's what happened. When we squared stuff, we introduced some algebra that can create solutions that are not quite right. So we have to check our answers to make sure that we're just getting the ones that actually work in the equation. One thing you could do, if you're on the graphing calculator and you wanted to check this, I'll just go ahead and tell you how to do this. What you could do is on your graphing calculator, on one line, put the left side of that original equation, and again, you'll change it to x. So we'll put like square root of x minus 2 plus x. And on the second line, put the right-hand side of the equation. So you're splitting it in the middle at the equal sign, and you're putting the left-hand side on 1y1 equal, and then on the y2 equal, you'll put the 4. And then what you'll do is you'll do second trace 5, that's that intersect function, and go look at your calculator and see where is it intersecting. If you look on your calculator, this one should intersect. Like you get 2, you'll get like a line like this, and you'll get something else going on where maybe you've got something like this, okay? I don't have my calculator pulled up, so I can't really draw it exactly, but what's going to happen, it only intersects at one point, and the point that it intersects at is going to be 3. You'll see that if you look at 6, it doesn't intersect there. That 6 might be way up here on this graph, and the line doesn't cross there. So it really only crossed at one point. And remember, when we do that, what we're doing is we're looking at those 2 sides of the equation as separate equations, and where they cross, that's going to be your solution. If it had crossed in 2 places, I would have had 2 solutions, but it didn't. It only crossed in one place, so I only have a solution of 3. Now, that does not mean that you can pull your calculator up and just tell me the answer is 3 because you looked in your calculator and got it. In math, when we're learning this stuff, we have to prove our work. And to prove our work, that is what you do when you show your work and you do it algebraically. So if you try that on the test, you will not get any credit. Just warning you. Or if you even do it on your homework, it's not going to work because you've got to show me the algebra to show me that you learned what you needed to learn. Okay, in 25 we have something different. We have 2 radicals. Well, I don't want to be squaring 2 radicals. I don't want to try to get rid of the radicals by squaring them while they're both on one side because I'm just going to create more radicals every time I do that. It's kind of counterproductive. So what we often have to do is we get one radical on each side, then we square each side, and then you're going to have to do it again. So you have to do it twice, but if you try to just square it the way it is, you're going to be doing it a lot more than that. Now, when you're going to do this, we need to move one radical. We need to get one radical on each side, okay? The procedure we're going to be following, I've kind of written off to the side. I want to get the most simple radical over to the other side. I'm going to move minus square root of y over there just because it's small. And in a minute, you'll see why I chose that. Okay, so I have 5 minus the square root of y. Now, I've got one radical on each side. What I'm going to do next, if it was a cube root, I would cube each side, but these are square roots. So what I'm going to do is I'm going to square each side. And the square root of something squared on the left-hand side is just going to be y plus 5. That one cleaned up nicely, didn't it? But over here, you got to realize this is 5 minus square root of y times 5 minus square root of y. So we still got a radical. Let's simplify all that. That's going to be 25 minus 5 square root of y minus another 5 square root of y is minus 10 square roots of y. And then minus square root of y times minus square root of y would be a plus y. All right. Now, I want to get the radical by itself. If you look, I've got one radical, and I want to get it by itself again. So we're going to move all the terms over to one side and leave the radical by itself on one side. As a matter of fact, it doesn't matter which side I choose. I'm just going to do this. I'm going to move my radical over to the other side just to make it positive. Okay, so this would be 10 square roots of y plus 5 is equal to 25 plus y. I'll just put y plus 25. Then we'll move the y and the 5 over to the right-hand side. So I'm going to subtract y to move that one, and then I'll subtract 5 to move that other one. And these will cancel out. And I'll have left 10 square roots of y on the left-hand side, and on the right-hand side, the y's are going to cancel out, and 25 minus 5 is just going to be 20. Okay, so when I cleaned it up, this is what I have left. Now, again, I want to isolate the radical. I want to get it by itself, so let me divide both sides by 10. Those would cancel out, and I'd get the square root of y is equal to 2. And now, if I want to solve for y, I'm going to now square again. This is the second time I've had to square it, but you see it ends up, it sounds horrible, but after you clean both sides up, it's not so bad. The square root of y squared is just y, and 2 squared is 4, so we have our answer, 4. Now we should go and check it to make sure it works, and in this case it does work. And again, remember, you could put it in your calculator and see where the two sides of the graph cross. That would be your solution. That'd be the fast way to do it if you don't want to check it algebraically, or you can just plug it in. It wouldn't be too hard to check. Square root of y plus square root of y plus 5 is equal to 5. Well, if I think the answer of 4 would be 4, I would just plug in 4. Square root of 4 is 2. 4 plus 5 is 9. The square root of 9 is 3. Is 2 plus 3 equal 5? Yes, it is, so it did work. So checking it by plugging it in really doesn't take that much time. It takes me longer to put it in the calculator than it does to just stick it in something like that and check it.